In this problem, I'm going to use the same game plan as I did before, but this one has a couple more steps. So first, I'm just going to enumerate what the steps I'm going to follow are. First, let's take a look at the problem. My accidents are either minor or severe. Initially, 90% of my accidents are minor. My minor accidents have mean 10, my severe accidents have mean 50. And I see a loss amount that exceeds 20. So given that that loss exceeds 20, that's twice what my minor average is. So that means, oh, maybe it's a little bit less likely to have been a minor accident. Maybe it's a little bit more likely to be a severe accident. So the first thing I want to figure out is I want to say, well, what is the probability that I have a minor accident given the x is greater than 20? Or likewise, what's the probability I have a severe accident given the x is greater than 20? This is just like which side of the spinner did I come up on? Then I'm going to look at a couple of pieces. I'm going to say, well, what is the variance of x given that I have a minor accident in which x was greater than 20? Or alternatively, what is the variance of x if I had a severe accident in which my loss amount was greater than 20? And in fact, in addition to the variance, I also want to know the mean. So I want to have the mean and variance. And then the final piece of the puzzle, and step 3, is I want to combine these to get the final answer. I think that this problem is a little bit harder than, or actually a lot harder than a typical exam problem, in the sense that step 1 would be a legitimate exam 1/P problem all by itself, as would either step 2A or step 2B. So in some sense, in fact, even to a limited extent, even step 3 might be a legitimate problem by itself as well. So we're really doing 3 exam 1P level problems all in one fell swoop. That's part of why I wanted to give you this outline. So now let's look at step 1. I want the probability I have a minor accident given that x is greater than 20. And again, I'm just going to use Bayes' theorem. That's the probability that I have a minor accident and that minor accident then exceeds 20. I'm going to divide by the probability of my accident amount, the loss amount, being greater than 20. What is my numerator? There's a 90% chance of a loss being minor. What's the probability of a minor accident being greater than 20? Well, the chance of an exponential random variable being bigger than something is e to the negative something, in this case 20, divided by our mean. Then in the denominator, how can x be greater than 20? There are two cases. Either I have a minor accident, 90% chance of it being minor, e to the negative 20 divided by 10, or I had a severe accident. There's a 10% chance of the accident being severe, and the probability of a severe accident being bigger than 20 is e to the negative 20 divided by the mean of a severe accident, which is 50. So when I work this out, I get that 0.645 is the chance of a minor accident given the loss was greater than 20. And likewise, if I want the probability of a severe accident given that x is greater than 20, those are complementary events. That's going to be 1 minus 0.645, and that's going to be 0.355. For my next step, I want to understand the moments of these things. And so first, let's take a look at the expected value of x, given that I have a minor accident and that my accident loss amount exceeds 20. Now, what does that mean for us? The fact that I have a minor accident means I have an exponential random variable with mean 10. I want the expected value of an exponential random variable with mean 10, given that my variable, I want to have a name for it. Let's continue to call it x. So I have x is now an exponential variable with mean 10, in this case when I have a minor accident. I'm conditioning on x being greater than 20. What does the memoryless property say? The memoryless property says that the amount by which my accident exceeds 20 has the same distribution, if I'm conditioning on that, as the original loss amount. So let's look by how much does my accident exceed 20. So let's look at the expected value of x minus 20, given that x is greater than 20. That, my x minus 20, given that x is greater than 20, has the same distribution as x. So I understand that part. But I wanted the expected value of x, not the expected value of x minus 20. I can't just replace x by x minus 20 unless I also add 20 back on. or really add on the expected value of 20 add back on, but the expected value of 20 is just 20 because it's a constant. And the first piece is simply equal to 10 by the memoryless property. So that tells us about the mean. What about the variance? What is the variance of x given that I have a minor accident and that x was greater than 20? Well, again, the memoryless property tells me I understand x minus 20 given that x is greater than 20. So let's rewrite this in terms of x minus 20. This is the variance of x minus 20, which I understand, but I can't just replace x by x minus 20 unless I also add 20 on, conditioned that x is exponential with mean 10, and that's what it means to be minor, and we're conditioning an x being greater than 20. The fact that I'm adding on this 20 right there, that piece is going to have no effect on the variance because it's just a constant. What about this x minus 20 bit? That is, by the memoryless property, I have an exponential random variable greater than 20, conditioning being greater than 20, so x minus 20 is the same distribution, condition on being bigger than 20, as the original distribution does. So that right there is an exponential random variable with mean 10. So in other words, what I'm looking for here is what is the variance of an exponential random variable with mean 10? And the variance of an exponential random variable with mean 10 is simply the mean 10 squared. So my variance is 10 squared. And if I wanted to, I could also work out the second moment, right? Because what's the second moment of x, given that it was a minor accident that exceeded 20? Well, that's going to be the first moment squared plus the variance. So those are all of my conditional moments of x, given that it was a minor accident that was greater than 20. So that was one of our cases, but what about the other case? What's the expected value of x, given that I have a severe accident and x was greater than 20? Well, what was my mean in the previous case? It was the original mean plus this 20. You've just taken my exponential random variable and added on an extra 20 to it. Memoryless property says that just adds on the 20 to the mean. So this is going to be the original mean of 50 plus 20. So in this case, I'm going to have a mean of 70. The variance of x, given that you have a severe accident and x is greater than 20, conditioning on being greater than 20 doesn't affect my variance for the exact same reason as in the previous problem. This is just the variance of a severe accident, which is the mean squared. And we get that the expected value of x squared, the second moment, given that I have a severe accident and x is greater than 20, well, it's simply going to be my mean squared plus my second moment. Plus my variance. And now for the final piece of the puzzle to bring this all together, what's the expected value of x squared given that x is greater than 20? Well, let's actually just look at the expected value of x first. The expected value of x given that x is greater than 20 is simply equal to, I'm going to break it down in my two cases. The expected value of x given that I have a minor accident and x is greater than 20 times the probability of being in the accident times the probability that x is greater than 20, probability of a minor, given that x was greater than 20. Then my other case that I have is going to be the expected value of x given that it was a severe accident and x was greater than 20 times the same or analogous probability times the probability of a severe accident given that x was greater than 20. What are those different pieces? The first mean was 30. The first probability was 0.645. The second mean was 70. And the second probability was 0.355. And so I get an expected value of 44.2. I can do a similar thing for the second moment. I can't do this weighted average stuff if I'm dealing with variance. I can only do this with what are called raw moments, like expected value of x, expected value of x squared, and so on. If I want to use find something for the variance, I would use what's called the law of total variation, which I'm actually not going to use here because I feel it makes this problem take a little bit longer. But I mostly just wanted to mention that in passing. Expected value of x squared, condition x being greater than 20, is the second moment in the case where I had a minor accident, so 10 squared plus 30 squared, times the probability of having had a minor accident, given the information that we have, plus the chance of being in the second case. In the second case, my second moment was 70 squared plus 50 squared, and the probability of that was 0.355. And so when I combine those pieces, I get a final answer of my variance is 1,318.